For our simple model problem, there is an exact solution, and we can compare the finite element solution to the exact solution to see how the finite element solution is doing. Here is a comparison of the temperature between the finite element and the exact solutions. On the vertical axis, I've plotted the temperature. On the horizontal axis, I've plotted the distance along the bar. The black line is the finite element solution, and the symbols indicate the nodal values. And the dashed red line is the exact solution. And we see that the nodal temperature values are exact. So if I look at this nodal temperature value, this nodal temperature value, and this nodal temperature value, they match exactly with the exact solution. That turns out to be an unusual property of the 1D finite element solution, and you won't get this to be the case, for 2D problems and more complicated problems. The temperature boundary condition is satisfied exactly. So what I did was, I picked values for the temperature and the flux boundary condition, the length of the bar, the thermal conductivity, etc. And I assigned, I just picked that the left boundary is at 0 degrees, and you see that that matches exactly. And because what I did was I just assigned that boundary condition to that value. That's what you do with essential boundary conditions, and you can see that that's satisfied exactly. In contrast, the flux boundary condition is satisfied approximately. To see that, the flux, we look at the slope, because the flux is proportional to the slope of the temperature curve. And in the exact solution, the slope is something like that. And in the finite element solution, the slope is like that. And so you see there's a mismatch between the two. So the flux that we specify is not satisfied exactly. And that's usually the case. Whatever you have as a gradient boundary condition, like the flux, that's going to be satisfied approximately, i.e. the natural boundary condition is satisfied approximately. The essential boundary condition is satisfied exactly. And when we go to structural mechanics problems, the essential boundary condition is the displacement boundary condition. So if you're fixing, a particular edge, that's going to be satisfied exactly. But if you're putting a force, that's a natural boundary condition, and that's going to be satisfied only approximately.